This is all about solving and graphing inequalities. So we're going to start with one that looks like this, and we're going to use our same strategies that we use for solving equations. I'm still going to draw my line through the greater than or equal to sign, and I'm going to do my steps to get x all alone just like I normally would. So I have positive 12 and a positive x on the left side, and I have negative 3 on the other. So I want to get rid of that positive 12. So in order to do that, I'm going to subtract 12 from each side. On this side, I'm left with x is greater than or equal to, and then 3 negatives and 12 more negatives is 15 negatives. So I'm done. I've solved my equation. The next thing I need to do is graph it. So if I have a number line, I'm just going to draw a really quick one. I'm going to put negative 15 right here. So this will be negative 14, negative 13. I'm going to write it nicer so you can read it. Okay, so here's my number line. And I want all the numbers that are bigger or equal to negative 15. So greater than or equal to negative 15. So on negative 15, I am going to make my boundary point. And it is going to be filled in so that we know that negative 15 is a solution to this problem. And the numbers that are bigger are the negative 14, negative 13, negative 12. So going to the right. So there's my solution. Any of the numbers that are bigger than or equal to negative 15 are going to be a solution for this problem. So if I think about it, 12 plus negative 15 is negative 3, and negative 3 is equal to negative 3. So that's how that one works, and that's how we graph it. So let's try another example. I'm going to do the same thing. I'm going to draw my line through my greater than or equal to sign. This time I have x on both sides, so I do need to get x alone. And I have 6 positive x's on the left side, and I have 1 positive x on the right. So I'm going to get rid of the 1 positive x because there's more positive x's on the other side. So I'm going to subtract x from both sides. I got a 0 pair there. 6x minus x. Excuse my children. 5x is greater than or equal to negative 15. And I need to get x all alone. I still don't want 5x, I want 1x. So now I'm going to divide both sides by 5. So I get x is greater than or equal to, and then I have negative 15 divided by 5, and that's going to be negative 3. So my solutions are going to be all the numbers that are greater than or equal to negative 3. So once again, I'm going to draw my line. And I'm going to put 0. It doesn't really matter how you set this up as long as your solution is on there. But you do want to make sure traveling to the left makes the numbers get smaller and going to the right makes them bigger, just like on a normal number line. Okay, so x is greater than or equal to negative 3. So once again, my boundary point is going to be on negative 3, and it's going to be filled in, just like last time, because that we have that equal to part. And the numbers that are bigger than negative 3 are all the numbers going to the right. So there is my solution. Any one of those numbers when put into this inequality statement would make it true. All right, last one. All right, so this one is not too many steps. So we have negative 4x is less than positive 8. Now, the one thing that you need to know is if you come across a part where you have to divide by a negative number, you have to flip the signs. So I'm going to divide by negative 4 so that I get get rid of the negative x's. I want positive x's in my answer. So I'm also going to divide this side by negative 4. And when I do that, I'm left with positive x, but now my less than symbol becomes greater than. So I have x is greater. Oops, let's fix that. X is greater than, and 8 divided by negative 4 is negative 2. So because I divided by a negative, anytime you have to divide by a negative, you're going to flip the inequality sign as well. It's going to become the opposite. So here's my negative 2. And I'm going to put my boundary point. This time it's going to be an open circle because negative 2 is not part of our solution. But once again, it's going to be greater, so I'm going to the right. All the numbers that are greater than negative 2 make this true.